Is an overview of the position paper that the working group on research has launched this year in September. So we will start with the video with the presentation.
Ever get totally sucked into a video game? Like you're right there in the action.
Yeah, definitely.
It's pretty amazing how realistic those graphics are getting, right? But what if I told you that same tech, that stuff that makes games feel so real, it's about to totally transform entire industries?
No kidding, really.
Seriously. That's what we're going to dig into today. This whole world of augmented reality, virtual reality, and like a million other tech terms that basically amount to changing the way we do, well, almost everything. How we design stuff, how we build things, even just how we experience the world around us. It's all up for grabs.
You said it. And we're not talking about some far off future either, right? I mean, things are already changing so fast.
Yeah. You got it. So to help us decode all this, we've got excerpts from this research paper, and let me tell you, it's dense. We're talking about immersive triplets, Web 4.0. It's next level stuff.
Well, then let's get into it. What I always find interesting is how this stuff, these technologies, a lot of people only get a taste of them through gaming. But now we're talking about these things becoming like essential, tools that everyone's going to be using across every industry.
Exactly. And this paper, it doesn't mess around. They jump right into the deep end, starting with this concept of immersive triplets. Honestly, when I first read that, I was like, what in the world? You might break that down for us.
Not at all. Think of it like this. Imagine a digital twin.
Yeah, so like a virtual copy of something real.
Exactly. But then you add this whole other layer of sensory experience. So we've all heard of digital twins, twin models, whatever, objects, systems, you name it. But an immersive triplet, that takes it to the next level. We're talking data on how something feels, the sounds, maybe even smells. It's about making that digital replica a total sensory experience, not just visual.
Okay, so instead of just looking at a 3D model of, say, a new engine design,
right?
An engineer could like put on a VR headset and actually interact with it as if it were right there in the room with them.
Exactly. They can feel the different materials, run simulations, really put it through its paces, and all this before even building a single physical prototype.
I can see how that'd be huge for industries like manufacturing. Talk about saving time and money. Prototyping can be a real pain.
No doubt. This tech has the potential to completely change how we design and develop, well, everything really. Faster innovation, more efficient production. The possibilities are kind of endless when you think about it.
And speaking of futuristic tech, the paper also mentions something called spatial computing. It sounds like something straight out of Star Trek, to be honest. What's the deal with spatial computing? Where does it fit into all of this?
Okay, so imagine a computer that gets the physical world, and I mean really gets it, in 3 dimensions. That's spatial computing in a nutshell. Think about self-driving cars.
Right, yeah. They have to have some awareness of their surroundings.
Exactly. They use sensors, cameras, all that to basically create a real-time map of everything around them. That's how they navigate, avoid obstacles,
So it's like giving machines a sense of their surroundings. Like they have their own internal GPS, but way more advanced.
Exactly. But it's not just about knowing where they are. It's about actually understanding the environment, like really understanding it.
Yeah.
And using that understanding to interact with the world in a much more natural, intuitive way.
Okay, I see where this is going. We're talking about robots in factories that can work side by side with people, doing their things safely and efficiently, or even augmented reality interfaces where you're getting digital information overlaid onto your actual view of the world.
You got it.
Yeah.
And the crazy thing is, spatial computing, it's just one piece of this puzzle. This paper, it really hammers home this idea that it's the convergence of all these different technologies that's going to be truly groundbreaking. They call it a real digital virtual continuum.
It's like they took every sci-fi movie ever made and just threw all the cool tech terms into a blender. But in all seriousness, I'm really curious, what does this whole continuum thing actually look like in practice?
Picture this: a world where you can just seamlessly flow between the physical and digital. No hard lines. That's the essence of what they're calling Phygital reality. Another key concept from this paper.
Phygital, okay, you're going to have to explain that one. It sounds like something you'd order at a juice bar in the future.
All right, so imagine you're online, right? shopping for a new couch.
Sure, I've been there.
So in a Phygital world, you wouldn't just be looking at pictures or those basic 3D models. You'd throw on your VR headset and boom, you're right there in your living room, but virtually.
Yeah.
You see how the couch would actually look in your space, feel the fabric, everything.
That's wild. And I bet furniture companies would love that. No more showroom.
Exactly. But it goes way beyond furniture. Imagine a surgeon. They're in the middle of an operation and they've got these AR glasses on. They're seeing the patient's vital signs overlaid right onto their field of vision.
So then we move to the next step in presenting the goal of the paper and the context in which we developed the paper. So first of all, one of the important elements that in a way motivated us to develop the paper was the fact that immersive technologies are developing with the support of IoT, edge computing, and artificial intelligence. And as we notice, we have a huge development in spatial computing, AI-powered extended reality. We have a rise of digital avatars, intelligent connectivity. It's supporting the development of virtual applications. There is a evolution of the immersive application in different domains. There is a need for developing the next generation of Web 4.0 and cross-platform applications. And the IoT wearable devices are developing very fast. At the same time, we see that the future of the technologies have a huge market potential. And as you see, the immersive technologies have reached an impressive $493.5 billion, and it's expected that this market is increasing even more. So this was one of the reasons why we address the issues related to immersive technologies and combined with IoT, industrial applications, and spatial computing. At the same time, we can say that when we structure the paper, we consider that the paper aims to provide a comprehensive overview of the convergence between IoT, AI, edge, and spatial computing, and how they are applied to various industrial immersive applications across different industrial sectors. And this is what we will look today. In details, the transformative impact of this application across a wide range of industrial sectors. And you will see that these sectors include culture, heritage, manufacturing, automotive, energy, construction, mobility, logistics, healthcare, agriculture, tourism, education, and training. So as an important part in the paper, for each sector, the paper presents a thorough analysis of the specific application scenarios. It identifies the key users and the stakeholders and describe how these applications are implemented within a virtual world. At the same time, outlines the elements there are specific for the different industries that require immersive technology functionalities and detail the underlying technology layer requirements. And on the technology layer requirements, we will come back in presenting the concept that was presented by us in a previous paper related to the technology advancement for immersive applications. At the same time, we address a number of cross-cutting horizontal issues that are important for each specific context. At the end, the paper dedicates a number of chapters to horizontal topics such as trustworthiness, ethics, sustainability, standardization, and interoperability. We will come back to this by presenting shortly some of the challenges and future research trends in these areas. Considering the structure of the paper that addressed the application, we started from the important elements that we identify in describing the technology behind the immersive applications. So first of all, we started with this interesting three-dimensional picture where virtual, physical, and digital realities are converging in industrial environments. And we have a combination of industrial immersive technology that create distinct experiences by merging the physical world with the digital and virtual reality. At the same time, when we describe each application, we consider and we had in mind the technology stack that we have to consider when we implement an application, starting from AI, edge AI, from sensors, to network, spatial computing, edge computing, blockchain, and interfaces that are needed. And of course, you have a number of functions that you have to consider in these applications, like sense and act, distributed intelligence, space and motion, low latency, and optimization. So now coming to the structure of the paper. So we have organized the paper having an executive summary, a chapter presenting the goal for the paper, a chapter describing the industrial immersive continuum background, and then we move to describing one or two or several use cases in different industrial domains. And you see that we cover culture and heritage, manufacturing, automotive, energy, buildings, mobility and transportation, healthcare, agriculture, tourism, training. And for all these use cases in the different industrial domains, we presented the scenario in which the use case was developed, the users and stakeholders, the implementation in a virtual world and the added values that the application is bringing, the required immersive technologies functionalities referring to the technology stack and the technology layers requirements, and a number of horizontal issues and characteristics specific for that use case. The paper has, at the end, 4 chapters that address the common horizontal issues that are applying to all the use cases. And these issues are trustworthiness, ethics, sustainability, standardization, and interoperability. The paper ends with a conclusion and extensive list of references. I will stop here with the presentation, just mentioning 2 of the horizontal elements that are very important, and then I will pass on the microphone to Valerio to present the other 2. And after his presentation, we will continue with the presentation of a number of selected use cases from the paper. So first of all, trustworthiness. This is an important element, and a future research should focus on interdisciplinary approach to building trust in immersive systems. At the same time, there is an important challenge in addressing the interplay between technical, social, and ethical factors. At the same time, there are a pressing need for creating, when you develop the immersive technologies and the immersive applications, an adaptive security framework that can dynamically evolve to identify and neutralize emerging threats in real time. So this is a real challenge that the researcher will have to address in the future. At the same time, as immersive technologies are converging other technologies, including AI, Some of the elements that are brought by AI have to be explained to the user. And then explainable AI will be crucial for making the decision-making process of these complex systems transparent and give a greater understanding and trust from users. Then, if we look at the sustainability is another very important part, and the sustainability has to be seen from different points of view by balancing economic growth, social equity, and environment protection. And redefine the concept of sustainability in the virtual worlds and immersive technology. It's very important because in virtual worlds and immersive applications, the concept of sustainability must include the use of resources, the natural resources like energy, the management of data, AI models efficiency and performance, connectivity, because as well consider that we have to have continuous connectivity in some of the application in order to synchronize the information that is in real world and in the digital world. And the sustainability can be achieved by incorporating green technology, promoting digital transformation, and using a more secure and transparent methods for managing efficient data and transactions. With this, I will pass the floor to Valerio to present the other two horizontal issues, and then we will move on with the presentation of the selected use cases. Valerio, the floor is yours.
Excellent. Thanks a lot, Ovidio, for handing me over. I'm going to share my screen. I hope you can see it. Can you see it? I'm told it's shared.
Yes.
Yes.
Yes. Okay, good. So I put it in presentation mode, and you should see even better. Is it true?
Yes.
Yes, excellent. Thanks a lot. So, welcome everybody. I will touch on two small aspects, let's say, but horizontal ones, as a video sketched before of the paper and white paper we have been working together. For those who do not know me, I'm a director of research and innovation. I work for Intel. I'm based in Munich. And the input to these 6 slides plus one are also coming from a couple of European funded projects called the Multics and 6G Aero. So I will discuss about ethics first, and let me stress one important point that we elaborated more depthly in the paper. As immersive and spatial computing applications and the underpinning IoT edge cloud continuum become more and more integrated in society, they also raise ethical challenges. Due to the fact that technology can influence perception and interaction between people, can create new kind of interaction, can change the behavior, can change the reaction of the people, can even form opinion, as you know, and steer masses at the end. So the capability of the new technology, especially if they are virtual or extended in some way, to really steer the masses into the direction that someone wants to, is becoming to the forefront. And so ethics is more and more of a concern and more of a challenge that we as a community need to tackle in order to have our product being successfully launched into the market, and at the same time not to create harm to the society we are all part of. Among the challenges, I would like to stress 3. The privacy. You know that Internet of Senses that is going to come will harvest personal data, but not the normal ones like password or, let's say, our preference for the browser, but also neural activities, biometric info, and emotions, which is never heard before. You may know now that with Wi-Fi, you can have a special signature of a single body of a person, because that depends on your fat, that depends on the bones you have. And so just with the out-of-the-shelf Wi-Fi that you have in your computer, ideally, one could have, with the proper algorithms, a signature of the person who is in front of the PC in 3 meters radius from the antennas. And you don't have to have any camera, any microphone on to spot who is in front of the PC. This is a game changer. Think about that in different scenario and potential use cases. It's really a devastating thing. Challenge 2, manipulation and deception. So real and virtual boundaries will disappear. So people will be used most probably in a specific vertical market, but also maybe for entertainment and education purposes to live in an enhanced, at least if not fully virtual world. So that will weaken the capability of people to spot what is real and what is not real, right? So avatar can better exploit emotionally people that leverage on psychological vulnerability. So this is something that we all should be aware of and take appropriate measure to counteract this threat. It's a challenge. It's not necessarily a threat, but it could become a threat if we don't act swiftly. And the third one is the accessibility and equity. So the digital divide will become even more evident with direct consequence on education, careers of people, and social participation in public clusterings and public activities. What are the obstacles? So the pace of technology development is, as you know, very fast. So the world is quite different now from 3 or 5 years ago. The decentralization and scattered solutions are difficult to tame. So, making something that works for the German law would not necessarily work for the Italian law or for someone who lives in Korea. Commercial interest versus ethical consideration. Data monetization is now on the forefront since a few years. And, people smell the money and go for it without thinking about maybe not doing that on purpose, but just because it happens, of the consequences of what is done. Complexity of the technology stack, because now we are thinking of sensors up to the application layer, all that is in between in the IoT edge cloud continuum. Think about the complexity of this multifaceted matrix. And then translate ethical guidelines into engineering approaches. This is something that we as engineers are not used to take some non-STEM, let's say, input in our working methodology. So we would have to learn and synergize with other skill sets. Moving forward, ethics framework and guideline to be adopted in all future products, specifically tailored for the virtual worlds, are needed. And they are supposed to strengthen transparency, fairness, to provide unbiased solution, and to strengthen the position of the human in the loop that should not be avoided. Advanced privacy preserving techniques are more and more needed, like federated learning or gossip learning is something that is even coming to the foreground, especially for the IoT applications, and use of decentralized system based on blockchain technology. Integrate by design those aspects in all future products, helped by powerful AI-based methods and effective governance models. New community-based approaches are needed in order to make that happen. And of course, advance in explainable AI towards the needed requirement of the IoT edge cloud continuum and the virtual worlds. The second topic is standard. We easily could spend a couple of hours just to introduce the complexity of the standard in the domain that we are talking about, but I will have only 3+1 slides. So for the IoT edge cloud continuum to function properly, and an aligned and comprehensive standardization suite of protocols is needed. And with that, I mean the interfaces, the protocols themselves, the messages, and the data formats that are part of those messages that are contained in those protocols that move between interfaces. So you see, it's a quite difficult to tame hierarchical approach, this one that we have to face. Interoperability can be guaranteed only through the availability of applicable standards. As you know, different companies, SME, industrial partners provide pieces of the system, and this needs to interoperate since day one of the launch in the market. This is quite challenging, as you know. That's why standards are so important. Extension to existing standards and even new standards are therefore needed to make that happen. Some key ongoing actions, the OpenXR that provides a common API for VR and AR hardware, the universal scene description that provides 3D address representation, but even probably also more interesting, the GITF, which is called the JPEG of 3D, that provides interoperable formats for 3D assets. And then, of course, the usual suspect, 3GPP, ETSI, and ETSI, no, I should have written the IEEE, ETSI 2 times. Protocols for real-time communications. There are a lot of announcements in release 20 of 5G, and then forthcoming release 21 that is supposed to be the first 6G release. We will see a lot moving into that direction. The virtual world partnership that has been launched recently, and the metaverse standard forum that has been established. So these are a few of the key ongoing action that we should have a look at in understanding how the world moves. What are the challenges in standards? The market fragmentation, no need to tell. how to achieve interoperability of a plethora of formats and protocols, and the rapid pace of innovation makes standards quickly potentially obsolete. You know that the cycle of standards, for instance, in 3GPP take at least 18 months, if not 2 years, for one release. Think about new things that come into the market or new algorithm that can change drastically everything that we know from year 1 to year 2. So the pace of standards is not on pair anymore with the pace of technology. Moving forward, this is my last slide. So what we should look together at to make that happen: semantic interoperability, ensuring that the meaning of data is understood consistently across different systems. This comes with the use of common technology and data models and interplay among the different data spaces that are popping up like mushrooms a bit everywhere from the different vertical markets and sectors. We need also framework for cross-platform identity and data management, integration of AI with standards, considering also EU regulations, and there's more than one. I mentioned a few of them, but there are easily more than 10 if you look at cybersecurity aspect, etc. Collaborative effort among the main stakeholders are needed to make all the above happen. That's why IoT is very important, crucial, because we as a community play a crucial role as we as an association act at the intersection of many of the mentioned technology and can address the highlighted challenges best than many other players. Thanks a lot, and I'm with my presentation.
Thanks a lot, Valerio. So now we are moving to the next part of the webinar, which relates to the presentation of a number of selected use cases from our position paper. So as we have Leonardo ready to go, I think we can start with him. You can share the presentation from your computer. We have as a backup your presentation, but we consider that probably it's better that you present from your own device. So you will present the work that was done on the meta break. And
yes, are you seeing my window?
We see.
Okay.
Yes, can see.
No? Sorry.
Oh.
Okay. Well, first of all, please let me introduce myself. My name is Leonardo Cattaneo. I'm a researcher and lead XR developer at Consortium Telemec. I'm one of the developers who has worked within the MetaBreak project, which is a research project financed by the Ministero delle Imprese del Made in Italy, also called MIMIT, which is an Italian national ministry. It started in November of 2023, and it is going to end in November of 2026. And it has the goal of evaluating the industrial metaverse as an enabling tool for the product production process co-design within the automotive component sector. The driver behind this choice is the fact that lead times are becoming shorter and shorter, while product complexity is also increasing. So the automotive component manufacturers are looking for instruments that allow them to parallelize as much as possible the development process of the product and the production process of the product itself. So basically, in order to build an industrial metaverse, we first had to carry out an analysis of scientific literature. And from this analysis, we could we have chosen to build an industrial metaverse made up of a chain of 3 softwares. The first one is a PLC logic simulation environment. The second one is a PLC logic mechanical simulation integration environment. And the third one is a mechanical simulation environment. Each one of these is connected with the adjacent software. So the first one connects to the second one, and the second one connects to the third one. And in this system architecture, the VR headset connects to the mechanical simulation environment. after establishing this kind of macro architecture, we went ahead and selected from what is available on the market without trying to develop custom software, a software for each one of these three categories. So for the first category, we selected Siemens PLC Sim Advanced. The second category, we selected SIMIT, still from Siemens. And for the mechanical simulation environment, we selected Unity 3D. As far as the VR headset goes, we selected the MetaQuest 3, which is the most vastly available XR headset. We chose to use off-the-shelf software as much as possible because we wanted to create something that was as familiar as possible to those working in industry, and developing custom-made software, although it probably would have yielded better performance, would have posed a significant obstacle to industry adoption. Well, I'm sure all of you know the definition of metaverse, but creating a system for the mechanical simulation that is visualized in a VR headset without multiplayer would not be an actual metaverse. So a part of our early research and design process was spent on the establishment of what multiplayer architecture would we adopt going while developing the project. Basically, we developed two proofs of concepts. One is the multiplayer application-based, and the second one is the multiplayer browser-based. The application-based one is simply consists simply of a compiled application installed on the VR clients, which can be either directly XR headsets or computers to which the XR headset is connected, while the second one is a browser-based system. So the client just connects to an HTTP address and they can pull the metaverse as a web page. Each one of these architectures has its flaws and its pros, but for performance reasons, we went with the first one, the multiplayer application-based, because it yielded lower latencies. We have up until now tested all of the components on a simplified use case. Basically, we have taken a didactic, an educational didactic machine that is owned by Politecnico di Milano, and we have created a metaverse version of said machine. We are now working on applying this kind of system onto a vastly more complex machine, which is the one that you are seeing now, which is used by Brembo to produce this new kind of brake caliper, which is fully electric, and it's an assembly station that is composed of a pick and place that has two electric axes, which are going to be emulated in its in-depth dynamics by using the Profi drive blocks within SIMIT, two robots, which are going to be simulated just within Unity. No robot controller is going to be involved in this case, and three vertical electric servo presses, which are going to be controlled again as electric axes through the Profi drive telegram inside of SIMIT. Are there any questions?
I think we have to open the floor for questions to you. Maybe I can start with one question, because if you go back to the slide on the architecture, This is, in a way, an important, this one. It's an important.
This one or the earlier one?
This one. It's
Okay.
an interesting illustration on actually what we presented in the paper. The fact that we would like to have more and more of the processing at the edge. And maybe you can comment on this element related to the fact that the Unity server, I guess it's at the edge, and the processing is done at the edge in order to obtain the low latency that you need.
Well, actually, the Unity server is not necessarily at the edge, but it's going to be local. It's not going to be like some cloud instance on some AWS server. Because in this case, rather than achieving very, very low latencies, as low as possible, the goal for the company was to protect their intellectual property. There's a lot of resistance in the mechatronics sector when it comes to the concept of cloud-based hosting. So we are working on an architecture that is entirely local, but it won't be a LAN-based system because it has to connect to Unity's relay server for the transport systems between the Unity server and the client applications.
Perfect. Thanks a lot. Other questions? Maybe I continue with the same idea on the development of the software. Have you used open source components? Have you developed open source components in this application?
Well, there are some, let's say, cosmetic packages inside of the metaverse application that are open source, actually. But the issue is that on the mechatronics side, so PLC Sim Advanced, TIA portal to develop the code that then gets run into in PLC Sim Advanced, and the CMIT environment, there are no widely adopted alternatives that are open source, because we are talking about a sector that is absolutely dominated by a single company, or at least in as far as the specific automotive component sector in our specific geographic area is dominated by a single company, and this company does not release these applications in an open source form. Unity 3D is not open source in and of itself, but since it's a very modular platform, components that we have developed may be turned open source, but are not at the moment. Some open source components were, on the other hand, used during the development, but mostly on the cosmetic side, like the avatars, like some graphic aspects of the machinery itself.
Thanks a lot. And if you allow me, one more question related to the AI components. Have you used AI components?
No. Well, aside from the obvious code writing assistance, we have not used AI to develop the system itself, but the key aspect that I would like for everybody to take away is that creating a system like this is an AI enabling tool, because you will get as close as possible digital twin of your machinery, and you will be able to integrate in this very open system, robotic agents that can be trained to substitute like humans for specific tasks. Let's say that 5 years from now, the company for which we have developed this will want to swap out their workers that load the parts inside of, I hope you can see my mouse pointer, inside these vertical loaders and inside of this vibrating loading parts with a robotic agent. They're not going to have to develop it in the physical world. They will be able to develop it in this virtual world and test the control algorithms, the navigation systems, even the camera systems, but using virtually generated data.
Thank you very much. If there are no other questions, so I propose to move to the next presentation. We have Kostas Lupos, which will present the enhanced XR human-robot interactive collaboration for welding operation. So Kostas, the floor is yours.
Yeah, sure. Just give me a second to load up the PPT. Okay, and let me share. It should be done. Do you see it well?
Excellent.
Should be done. Do you see it well?
Excellent.
Okay, great. So I'm not going to go into that much detail as the previous presentation because I had in mind that just 5 minutes that we need to present. So I'm Kostas Lupos. I'm representing Connecta Systems here. I'm also a consultant in Illecom Innovation, so you may have heard me with this hat. Connecta System is just the commercial spin out of our research entity, so very close, working very close together. And we present you this enhanced XR human-robot interactive collaboration for welding operations. It is a project that was finished a few months ago, just less than 6 months or something. And it was just 2 partners participating in this, Connecta and AIOTI in Greece. So yeah, before I start, let me explain the concept around it. So it was using XR supported by modern technologies like voice commands or visual languages and also audio interfacing to control a robotic welding machine. This includes a robotic system, a full robotic system, including an arm. This was an off-the-shelf robotic arm that was used with an end effector of, as you will see in my next slide, an end effector that is able to perform welding. So in this project, we work together with AIOTI, which is a company that is building robotics, and they are also responsible, and they have built this robotic interface to perform actual weldings and in various industries. It was hard, heavy manufacturing, but also it related also somehow to the bikes in industry because they're using precise welding operations in this sector, and this is where also robotics could sound beneficial for them. As you can understand, we're talking about an industrial environment, and the welding operation is also having inherited dangers and risks for the people around it. Not only high temperature, but also radiation, things like this. So it can be considered as a quite heavy task. This is up to now mostly manually performed in knowledge forms. So what we developed was an XR interface that we are able to command orally the execution of the experiment, of the welding operation. And this included also commands for directing the robotic arm, but also configuration parameters like how great current to be used, what materials we're welding, what's the particular glue to be used, etc., etc. And then the operator also was able to control the welding arm by hand gestures and virtual buttons within the XR environment. So the operator was wearing this XR helmet, and of course he was able to receive feedback and safety policies and safety warning risks, things like that, all supported by visual language and visual language models for this two-way feedback. The XR application was also developed based on Unity engine, on the Unity engine. On the right hand side, you can see the actual robotic arm that was, if I remember, a JR2 robotic arm. And at the end, as I said, it was using an end effector with the welding tool. The main features implemented in HoloLens 2 and ROS 2, of course, compatibility, and we created a digital twin of the robot and its live state, surrounding environment, as you can see on the right, on the top image. And there was also a preview of the robotic arm motion plan. So there was a preview even before doing the actual execution of the welding, and also a real-time visualization of the actual welding scene during the operation in real time. On the bottom slide picture, you can see the interface for the user. So he was able to power on, power off, return to home, etc., etc., and also provide some settings, but also some welding parameters, as you see in the rightmost area. The achievement was to achieve a close to zero command error rate in terms of interfacing with the user, and real-time response time, which increased the efficiency of the system and, of course, the user satisfaction during such efforts. Again, on the robotic arm, you can see the physical apparatus here. Well, in this case, this robotic arm was used, but we were quite generic in using whatever robotic arm controlled via the ROS 2 application. And this included some sensor integration for safety, mostly, but also for the actual execution and measurements for the trajectory of the robotic arm. So for environmental perception, we have integrated the 3D laser scanner and the laser SIM tracker as said for the actual welding. The robot was able to optimize the motion plans regarding the position of the actual welding plates to be welded. And we have done a series of real-life testing with actual welders. And as I said before, it gave us the opportunity to have actual welding operators with us to test the system, but also to see in real time what's the accuracy that we can achieve, which was defined at millimeter level, and the precision that we managed to achieve was very, very well. And another performance parameter was that the welding time was dramatically reduced, especially if we are talking about repetitive tasks. This was very, very much highlighted by the end users and the operators of the tool. This was very important for them because it might be the case that they have to weld, 200 angular, metal plates, in a day. And if they wanted to do, different things and different welding actual tasks within a day, this system or such a system wouldn't be very much helpful for them because the configuration time was high. On the other side, if there is a repetitive task, as I said, it proved very, very beneficial for them because they set it up once and they just leave it to work on its own. They just replace the plates and stand, quite far and, in a safe distance. We had the opportunity, as I said, to come close to these guys because they were from the manufacturing domain. But we have seen a lot of improvement in the social and working conditions, as you can understand. It's very safer, the quality is much, much better, the performance monitoring is much easier and quicker, but also environmental aspects like greener operations, quicker operations, etc., that can lead to environmental savings, etc. Another important thing that we discovered during the experiment is that this tool and this set could be useful for other industries like the bike industry, for bike manufacturing, because this is where they need a lot of precision, and it falls into the category of repetitive tasks to be executed on the field. Yeah, I think this is it from my side. I don't know how much time we have left.
Thanks a lot, Kostas. So we have some time for a few questions. So the floor is open for questions from the audience.
Sure.
Maybe again, I will start with a question because it's a very interesting application. And for me, two questions that I have. One, it's related to the integration of the ROS2 with the virtual part of the application. And the second one, it's related to the real-time performance. You mentioned that the system has a real-time latency. And
yes.
Then related to this, what kind of connectivity you are using for the implementation?
Yeah, thank you. Very good questions, both of them. For the ROS operating system, we use the ROS. So any tool regarding this compatible with ROS2 can be really used regarding the robotic side. And we connected this with the Unity 3D, but also mixing with mixed reality using HoloLens, Microsoft HoloLens interfacing. We use the interaction with the XR environment through an REST API, so open API interfaces, just for completeness. Regarding the latencies, it is true that we had some latencies in the interface. So practically, we face that during if you are acquainted and you know very much, you are into technology, into XR technology, you have seen other applications, it wouldn't bother you. For example, myself, I wasn't that bothered by the slight latency that we had, but in real life and in real operators, they were expecting, real-time video streaming, like something like that, as if they are, looking with their own eyes. So we didn't practically achieve that. As you can understand, it was a bit difficult to achieve really real-time responses from the system. But the latency was quite low, I would say, in my experience in the XR industry, I would say. So, for example, it was in millisecond level, not even a second. At least the interfaces that we use. Of course, I think if we want to take it to another step, it would be good to see the most powerful apparatus to be used, more CPU power, so that you accommodate with some of this latency, because there was also real-time, motion detection and speech detection, etc., running in the background of this. So these were also might be delaying also the whole process. Lessons learned is that okay, we use the local implementation because we wanted to be as close to the environment of the actual welders as possible. So we have used a server that they were using, not that powerful, I must say. So in our company infrastructure, it was working much weaker, but still there was some latency, I can say. So using a bit more lightweight algorithms could be one solution, and of course, a stronger CPU could be beneficial for this to improve the latencies.
Thanks a lot, Kostas. Other questions from the audience? If not, thank you very much, Kostas. Very interesting application.
So
and we are looking forward for seeing the next step in your work. Thank you very much.
Of course. Yeah. Thanks, AIOTI. Thank you.
Thank you. So now we move to the next presentation from Nuno Sousa, collaborative aircraft cockpit design. And Nuno, the floor is yours.
Hi. Can I share my screen? I think so.
Of course.
With the aviation company. And the idea it was they do refactoring of cockpits of the planes. They will go to the planes and they do that physically. The idea of the project is doing that virtually, completely virtually. So the idea is first test the final cockpit. So instead of physical mockups, we do a virtual mockup. So one problem that normally exists in this process, they have to validate the cockpit with the pilots, and they are not so available for that, for doing that. So the idea is to have a shared MR space that in this case will be a VR for the technicians and augmented reality for the pilots. So they can do it more at a distance, and they do it more with more flexibility. So they can have a shared space for doing this. Is a kind of negotiation of the final cockpit. So what we developed in the project, we developed that is called E2IM, Intelligent Aircraft Modification, I think. And we have done a virtual reality environment that you can see in the left, and where the engineer creates the cockpit. So you can put the equipments on the position of the cockpit. It's a blank sheet, so you can go to a library of templates with equipments, and then you can place them. Then we have some functionalities to see if you can put equipments side by side or not. You have some priorities for doing that. And then you can construct a cockpit in the virtual environment. Okay, so the idea is I am seeing some feedback. I don't know. I don't know. It's Romin, if you can. I can.
Please switch off the microphones if you are not talking. Of course, the others, not who's speaking.
Okay. So we have augmented reality application for the pilots, so that you can see the alterations of the engineer, so they can discuss, so they can have some iterations to go to the final cockpit. Only the final cockpit will be physical implemented and constructed. The idea is that all this process is done virtually in this phase. So the pilot evaluates from first review what the technician creates and edits. And we can have also some synchronous sessions with real-time changes, and they can, because in the initial project it was asynchronous, so the technician do something, And it was only VR. The idea of these use cases that done with the different technologies, VR for the technicians and augmented reality for the pilots, and they have a shared session. They have these mixed environments. So the idea, the project was, as I said, VR for engineers, I have for pilots. We use, in this case, we use Unity, but we can use also Unreal. These are two game engines, or most common game engines that that are used in Share applications. Is the idea in kind of in the communication? Of course, we should have a low latency edge infrastructure so that we can have a good communication. The idea of interactions, we can use a lot of the usual input mechanisms. In this case, we used VR controllers because, as I said, this was the project was done some time ago, but now we can use DNs and gestures, can be hand tracking. We can also use voice commands. In this case, we have some voice recognitions for doing notes, put notes in the 3D environment space. So we can use voices. And of course, for that, we should have some good microphones. And optionally, we can also feel the cockpits, and we have some haptic gloves for doing those kind of feeling the cockpit. The data can use the cockpit's 3D cockpit itself. Of course, the modelation of modeling of the 3D the cockpit. We can insert some telemetry, and we have also session recordings because as it is a process, iterative process. The idea was to the technician engineer can do some alterations, put some notes, the pilot can see them, and we have this kind of process, evolutive, incremental process and they can discuss at least asynchronous. If it is synchronous, of course, they can talk with each other. Also, we can do some things like computer vision for seeing if how the pilot is interacting with the cockpit. And also we can do some kind of natural language processing for seeing, analyzing this information that is generated. The idea, the main idea is, of course, fewer physical mockups. They do it physical, of course. They do some experiments, so that can achieve the best cockpit, and that means that they do physical constructions before the final cockpit. This is waste, physical waste, probably not reusable, and the idea that is not doing so much of this. If you can do it all virtual and then only the final physical cockpit is constructed, it should be better, of course. The idea is also faster design cycles, achieve a better ergonomics with this negotiation, this communication between engineer and pilot, and of course lower material use and energy consumption. The idea, of course, we have to implement secure data handling. It's a sector that are sensitive, of course, like others, but aviation, it's a very sensitive sector. We should talk about redundancy and also fault tolerance. And most important, all that is done in a virtual environment or augmented reality environment should comply with aviation regulations because they have to validate the final cockpit, and that is, of course, a rigid process. The idea, of course, if you are using different things we are receiving biometric data, we should be careful of that, and we have to follow the specific standards for that in terms of privacy. We should also user consents, and we can include some AI algorithms. Of course, we should be aware of bias of those algorithms. The idea is also to be the accessibility, because normally a cockpit is done so that the pilot and also, of course, we cannot do a system that does not fulfill the specific flight simulation standards that we have. So is because if not, the application will not be useful. They will not be able, even for to be used. And the idea is, as I said, fewer physical prototypes and reduce resource consumption. And is that? It's all.
Thanks
Any
a lot. Thanks a lot, Nuno. So the floor is open for questions.
I would like to ask a question, if that is possible.
You are welcome.
Okay. What is the most challenging aspect of designing an immersive software environment for designing airplane cockpit? It's a generic question, but what is, for example,
if anyone is talking, because I'm not hearing anything.
Oh, can you hear me?
So Nuno, I think you have to check your.
No, I am here. No, I'm here now. Okay. Can you repeat?
All right.
Please repeat the question.
Okay. What is the challenge, most challenging aspect of designing a software?
Can you repeat it?
Okay. What is the most challenging aspect of?
We're hearing a video, no, but not say that.
So okay, maybe I can.
Sorry.
Okay,
I
no,
can
yeah,
I'm hear hearing. Me? Do you hear me, Nuno? Hello.
I see the things.
Okay.
But not hearing again.
We lost Nuno. I think.
So Sedat, maybe you can repeat the question.
Okay, can you hear me?
Now, yeah, now I hear. Yeah.
Okay. Okay. What is the most challenging aspect of creating a virtual reality software for designing a cockpit?
The most challenge is the people, is the available of the pilots. As I said, we have to test, of course, to be achieving the requirements for that. And normally the first engineers we achieved the availability for that, but the pilot is a very occupied person. So the idea is that is for them also. And was that in terms of the development of the application, we didn't have any difficulties. We were used to do different applications with different frameworks and devices, and didn't have any difficulty for that.
Okay. Thank you very much for your answer.
So, thanks a lot, Nuno. Again, a very interesting presentation, and with a lot of potential in the.
Anyone? Any more questions?
Okay, I think you don't hear me. Thanks for your presentation. I think there are no other questions. So then we move to the next presentation from Udayanto.
I think we can switch to the next person, I think. I don't know if your video is talking because I cannot hear.
Yes, I'm talking and.
Okay, now I'm hearing.
Right. So Udayanto, please take the floor and share your screen.
Yeah. Thank you very much. I hope my voice is audible.
Yes.
Yes, we can hear you. We can see you, and
okay,
now we are waiting for your presentation.
Okay. Let me. I hope now I'm sharing it properly. Let me move to.
Yes.
Okay, so thank you very much for the time to exchange our ideas and recent activities. So my name is Sudayanto Atmojo. So I work as a staff scientist at Aalto University in Finland. I'm particularly working in a test setup laboratory called Aalto Factory of the Future at the university. And today I will be, let's say, sharing what recent proof of concepting work that we've done, linked to a couple of projects. The title of this proof of concepting is called Automation and Immersive Visual Augmentation, including real-time indoor positioning for decommissioning technicians. So when I mention about decommissioning, this is actually the scope of the work of the case that we are using as a starting point for the for this work. But the idea of these technologies and the features and the benefits are pretty much applicable to different types of technicians. But we chose this decommissioning as scope of the case. So when I mentioned about decommissioning, this is more or less like an activities done by expert engineers working to dismantle industry infrastructures, equipments, when the industry infrastructures are reaching the end of life. So often this involves quite hazardous environments. Let's say one example that is probably most heard of when we're talking about decommissioning could be nuclear power plants. And especially in the nuclear sectors, there is a lot of compliance and safety procedures that have to be followed. But of course, there are also other example areas where decommissioning activities are relevant. Could be offshore oil platforms or even factories as well. So the scope of problems that we're looking at in terms of decommissioning activities is that we have pointed out four of these points. So one is there is a lot of involved repetitive tasks, and especially looking at many existing solutions, they rely on let's say fully teleoperated solution, and the repetition that is being the nature of the repetition that is involving in the fully teleoperated solution is the efficient the cycles involved in doing this operation is less efficient, it's slow. At the same time, it reduces it affects the mental fatigue of the operators. And then another point here is that when the let's say the commissioning engineers, they have to go on site for certain cases, they have to try to navigate themselves to find the positions, the place where they have to carry out the work into commissioning task. This involves often the time spent can be longer just to find out where they are and to make sure that they are arriving at the location in a safe manner and also accurately where they're supposed to be. And then when they have to carry out their work, they often rely on let's say paper-based instructions, and at the same time, because if their hands are full, then this introduces difficulties, and of course, when the instructions are not arriving in the most seamless way, then they can introduce errors and requires rework. So these are a couple of problems that we depart to carry out the work. So for this to address these problems, we propose this let's say like an integrated solution. So one is an integrated mixed reality solution that will support the technician who are working on site. This includes as an interface which is based on mixed reality technologies that will guide and supervise, help the technicians to guide the machines and also perform supervision and also to control the setup. This setup that we use as a mixed reality is in an interface, and then they are facing a mobile manipulator, which is basically a robot that could autonomously and move autonomously to the spot that they have to carry out the work, for example, and to pick up some hazardous substances, for example. And this robot is able to carry to perform to work in more autonomous way, can detect autonomously the object, can pick and place and transport and dispose under the technician supervision. At the same time, this will include as well when the technician has to go to on-site and find out where they are. They are equipped with the information where on their positioning. So this includes a reliable indoor navigation. So this relies on technologies on ultra-wideband sensors that this will be installed in, let's say, in different places in the infrastructures, and then this will provide reference positions that will be provided to the technician to show where they are at any time and any moment. So this is the setup that we came up with. There are 2 slides of this that shows the setup. So one I mentioned about the mobile manipulator. So we built a proof of concept that is based on this universal robot platform, UR3, mounted on top of this mobile AGV MIR100. And then on this universal robot arm, we use Intel RealSense D405, which is able to identify where the location of the items and to be used as well for accurately find out the exact reference position of the arm against where the AGV is located. And then in order for the technicians or operators to use these mobile robots, this mixed reality interface provides this interface that will, one is provide a few displays. So as you see the image on the bottom, for example, it shows each of the necessary phase where the operations to pick, place and transport items have been carried out, and shows the status, for example. And then it also provides an interface to start and stop the robot to perform certain tasks in a let's say immersive way. And then at the same time, you see on the top right, it also provides an interface for the technicians to receive instructions on how to carry out the task and to perform step-by-step instruction for the engineer. And as for the indoor positioning setup, we rely on this ultra-wideband technology. For this proof of concepting, we placed 4 ultra-wideband as an anchors located in 4 positions on the corner of the space. And then we have, let's say, the person who is, let's say, acting as an operator or technician here. He or she will carry out this another additional device of the wideband, which acts as a tag, and this will provide the means to find out where they are in the locations, and this information will be provided through the mixed reality interface, which is of course rely on this Microsoft HoloLens platform. So based on this proof of concept, we aim to achieve the following impact. So to reduce the cognitive load of the operators with having, let's say, means of interfacing. And then the idea of providing the necessary information for the technician is to achieve the so-called first time right, to avoid, to reduce the procedural errors and to avoid any needs for rework as much as possible. And then, of course, when we're talking about positioning and helping them to find out where they are at any time, then this will reduce overhead. So reducing the unexpected time delay when they are navigating to the environment and arriving to where they are supposed to be. So reducing the time delay until the actual work can actually be performed. And of course, with this automation based on mobile manipulation and robotics, this will help in performing more efficient work cycles for the task. So I hope this gives a little bit of idea what would we do, and if there are any questions and if you're interested to discuss further, this is my contact detail. And as I mentioned, these activities are linked to several projects. So I would like to also acknowledge the projects below for providing us the necessary inputs, problems, and also the resources to carry out the work. So thank you very much for your attention.
Thank you very much. Very interesting presentation, and aligned with the presentation that were before. So thanks, Udayanto, for the very comprehensive presentation, and then we open the floor for questions. So again, maybe I will have a question for you. Why you have chosen ultra-wideband for real-time indoor positioning in the factory?
Yeah, so one of the main reason is, of course, this is happens to be in this following project that these are the emerging technologies that everyone is currently looking at to pilot, and this is also the same thing that we do. We took some existing devices from existing suppliers. Unfortunately, I don't have the slides here, but our aim is to test how the performance of actually this technology is, and we actually built our own firmware, and we managed to do some measurements to compare with other solutions, and it seems that it provides quite reasonable accuracy given the cost the cost of these devices as well. So this looks to be promising, at least right now, based on our study. So it can provide us with a solution which is very cost efficient, but at the same time, it can be very accurate compared to other competitive solutions. So this is one point that I can highlight.
Then a follow-up question: as you are using them in factory floor, how the equipment, the pipes, the metal content influence the precision of your location?
Yeah, so this is really good point. So far, we in our experiment we include some scenarios of, let's say, the person moving, and also we have also this AGV that moves as well. But of course, more stress testing I think needs to be done just to see the actual impact of different of the mobility of, let's say, assets in the space, and also as you mentioned this. Metals and so on, but it seems so far the impact is quite not very substantial.
Thank you very much. Other questions? If not, thanks again for the presentation. And with this, we can conclude our webinar for today. We thank to all of the participants for your involvement, and we invite you in future activities that are organized by the AIOTI Working Group Research. So the next meeting, we have it on Friday. We are addressing the Framework 10 challenges and future directions. And from next year, we will work on a different position paper that address the issues related to AI and the different flavors and the AI used in IoT and edge computing. So, Valerio, if you have some few words, please, and then Damiano or Damir as well, if you want to add to these closing remarks.
Thanks a lot, Ovidio. I just want to thank all the colleagues that attended and those that will hear us offline. I'm very happy about what we achieved this year, but I'm even more interested to what we are going to achieve next year. So please, it's a call of action to all of us to really stay tuned on the several activities that Ovidio and myself are driving in the research work group, because that will be an interesting task to us all, and also needed, let's say, input to the overall IoT community. So looking forward to collaborate with you moving forward with the next white papers and other documents and events. Thanks a lot.
To conclude, some words from me. Thank you very much, Ovidio. Thank you very much, Valerio, and all the speakers. I have to say that this is the last webinar of the year, And the work actually that was made by this working group, so with the paper, with the research working group, it was very amazing. The paper is very beautiful and very interesting, and a lot of people say this, and a lot of people read it. So I am very glad to say that your work was remarkable. Thank you very much. Thanks to all the people that came. You will find the recording on YouTube, and you will find all the materials on our website. Have a good evening, and thanks.
Thank you.
Thank
Bye.
you.
Thank you.
Bye-bye.
Bye-bye.
Bye.
Take care.
Bye.
Thank you.
Bye. Bye.